Good day. It's time for another short and sweet lesson. This time we are going to be discussing some basic mathematics. And in this process, hopefully we'll be able to clear up some misconceptions or mistakes people have. First of all, for algebra, it's all a question of isolating what you want. So if we do a simple addition problem, like A plus B equals C plus D, what is A equal to? Well, the simple thing to do is separate it out. Since these two are added, we need to do the opposite. So we're going to want to keep track of A, but in this case it is plus B is equal to C plus D. Now what I want to do is I want to subtract out the thing I want to get rid of. Since I'm looking to get rid of B on this side, I subtract it out. But the rules say whatever I do to one side here, the left, I have to do to the other side, the right. So since I subtracted a B here, I have to subtract a B here. Then I just come along and figure out, oh, I have A, and B minus B is nothing. This becomes equal to C plus D minus B. So that's what A is equal to. And you can rearrange the letters any way you like it, but it's always the same sort of a process. Let's try this again with something of a simple multiplication problem, such as speed is equal to distance divided by the time it took to get there. And this would be average speed. So we could write this as S with the bar above it, which means average, equals D over T. Now let's say I wanted to know what T is. Well, what do I do next? Well, first part here is, let's rewrite this, is I need to do the opposite. Since this is D divided by T, I need to multiply by T. So I make the multiplication symbol and do there. Now the rules are whatever I do to one side, I do to the other. So this becomes S times T is equal to D times T over T. Now anytime you have something above itself, that becomes 1. So this says D equals ST. And of course I have to remember to put the little bars there to indicate that it's an average. It doesn't get much more complicated than that, but you just have to remember, do the same thing to both sides and do the opposite of what's happening to it to remove it to the other side. So let's try one more here. I can do a fancier one, which is to say that the velocity final is equal to the velocity initial plus any acceleration multiplied by the time of the acceleration, because distances and acceleration, all that stuff, they're all going to be in units of meters per second, all that in the SI system. So in this case, let's say I want to know what T is. So I'm going to circle what I want. So in this case, these two, let's take this step by step. First of all, I have velocity final equals velocity initial plus AT. And of course, this is the guy I'm looking to keep up. These two are added, so I need to do subtraction. If I subtract velocity initial from one side, I need to subtract velocity initial from the other side. Now it looks kind of funny where I say plus or minus, but since I wrote it that way, now I can just clean this up and say velocity final minus velocity initial is equal to acceleration multiplied by time plus velocity initial minus velocity initial. Well, these guys are going to cancel out. So my final result is velocity final minus velocity initial equals A multiplied by T. And once again, I'm reminding myself that I am keeping there. There's no math reason to circle the T. That's just to help you keep track of this. So when this is done, I have these two multiplied by each other. So once again, just drag this out. And I'm sure some of you are thinking I'm dragging this out way too much, but velocity final minus velocity initial is equal to T times A divided by A. But if I divide this side by A, I have to divide that side by A. This then reduces to 1, which means T is equal to velocity final minus velocity initial over A. Now, it's a bit of a long-winded way to go about it, but this way always works. You always do the opposite of what you're planning on happening so you can get the result that you want. And it usually, like I said, helps to keep track of what you're looking for. Now, could I have solved this for A? Could I have solved it for B initial? Of course I can. Should we try to do that again? So let's take a look here. I start off with velocity final equals velocity initial plus AT, and this time I'm going to track velocity initial. Since it is added to this quantity here, I can say velocity final minus A times T is equal to velocity initial plus A times T minus A times T. Very quickly you realize these are going to cancel, so you end up with velocity final A times T equals velocity initial. Now I could rearrange it the other direction, but I'm saying the initial velocity would be your final minus how much you changed it. And of course we can then do this one more time to figure out what A is. So we say velocity final equals velocity initial plus, this time I'll change the colors a little differently, A multiplied by T. First thing to do, velocity final, since these are added, minus velocity initial equals T minus velocity initial multiplied by A plus velocity initial. They cancel out. So now I'm left with just this. Well, I have A times T. So, once again, following my pattern, velocity final minus velocity initial equals A multiplied by T divided by T. But if I do it to one side, I have to do it the other. So what I'm saying is acceleration is equal to the velocity final minus the initial over the time that it took to do it. This is also known as delta V, the change in velocity over time, which is the definition of acceleration, which we will use later. Hopefully that gives you a couple ideas, and we need to ask these questions in class and see how this all goes.